Hello everyone. A very good evening to all. Dear authors and invited guests, welcome to the technical session 2A. My name is Anisha and I am the moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Competitive Strategy, ICTCS 2022 through Zoom. I hope you will enjoy the knowledgeable interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 8 minutes for their presentation and 7 minutes for and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. Also, there is a request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Prashant Dhotre. Mr. Prashant S. Dhotre has more than 17 years of teaching and research experience. Currently, he is working as an associate professor in the Department of Information Technology of MIT School of Engineering in MIT ADT University. His publication includes more than 25 papers in the international conference and journals. His research interests include algorithms, privacy, and Turing machine. Welcome to the session, sir.
Thank you, and it's my pleasure to be part of this wonderful conference. Look forward for different and innovative content. Thank you.
Sure, sir. Thank you. So now we will start with the papers, and I would like to invite our first presenter, Anita HM, to present her paper on the title Attainment of Program Outcomes in Outcome-Based Education, a case study with operating systems course. So, dear presenter, you may please start the presentation.
Good evening, madam. My screen is visible to everyone.
Yeah.
Myself, Anita. I am going to present the topic Attainment of Program Outcomes in Outcome-Based Education, a case study with operating system course. So the contents what I am going to cover today in this paper is introduction, literature review, background, course delivery plan, observations and inferences, conclusion. Basically, operating system is one of the core course in our department, Department of Information Science and Engineering in our college, BMS College of Engineering. Outcome-based education mainly focuses on student-oriented learning with measures in terms of outcomes. Progress of graduate is normally measured through OBE model with program education objectives, program outcomes, and course outcomes. Major challenging what we are facing in engineering education is to delegate the effective and application level teaching. Problem based learning, whatever we have inculcated in our course is problem based learning, activity based learning, and seminar on recent trends in operating systems. So these are the activities which were carried out for the operating system course. Uh, so in the literature survey, we observed that most of the teachers they inculcated in their teaching in their courses different approaches. Some of them have used analogies which gave them benefits such as real world connection, students' knowledge in the subject. So the students' visualization was achieved using analogies. Some of the authors had mentioned that they had used simulators like OpNet. Then some of them had introduced the game-based techniques. Some of them have used interdisciplinary teaching learning approach. So basically, in traditional teaching process, what we have normally what we have observed is it is mostly teacher oriented teaching. And the teacher normally go to the class and use the blackboard or PPT. Students study from the textbook material provided by the teacher. Student write the exam and evaluation is done by the teacher. So this is normal process what is being done the traditional way. So information disseminated in this manner from the blackboard is one sided. So basically, we have several pedagogical approaches like think, pair, share, cooperative learning, flipped classroom, peer learning, problem-based learning, activity-based learning. So there are certain advantages or benefits with respect to pedagogical approaches. There is active involvement of students. Teachers' competency level is also increased, and with respect to the student, holistic development is achieved and the responsibility of the students is enhanced and the development of soft skills as well as collaboration with peers is being achieved here. So the course delivery plan, what we had planned with respect to our operating system courses, we had 3 hours of theory every week and 2 hours of tutorial was conducted. So the methods which were adopted in our teaching is we used simulator, we used activity-based learning, and we used alternative assessment tool here. So we basically it had two reviews wherein in the first phase, students were informed to form a team of four. Then students were asked to choose the problem based on their study from the papers, research papers, and research papers we had informed them to take from the latest years. Once they make a survey of all the work whatever is carried out, they would come up with one of the problem research gap, and which they could implement and give the solution for that particular problem. So this is so first review has been conducted wherein they present their research findings from the literature review. The second review wherein students demonstrate the implementation of problem what they have identified through the research findings, and later on documentation will be completed and submitted for evaluation. So here, based on whatever reviews were conducted, we took the opinion from the students. What is their opinion with respect to review one, and what is their opinion with respect to review two? So we had posed on some of the questions. That is, what is their level of understanding towards the topic? What is the how did they understand? They are able to understand how to perform research analysis, and then was your work sufficient and needful towards building knowledge? Was the time given to analyze is sufficient? Rate your learning from your team size. We found that most of the students were happy with the approach, and we found mixed opinion, but most of the students, as per our analysis whatever we have done, so we have found most of the students were involved in this activity. And review two also we had posed, we have taken the feedback from the students, and whatever they have provided, from that we got to know that the review one and review two whatever we have conducted for the students had enhanced their learning capability. And through this, with the observation and inferences, what we could draw is review one contributed towards some of the PO attainments like PO9, PO10, PO11, PO12. PO9 is individual as well as teamwork is achieved. Communication, students were able to communicate better. Project management, they were able to do here. Lifelong learning, whatever is being learned. And then review two, the program outcomes which were mapped is design and develop the solutions. Since they had found the problem in the review one, they were able to design or provide the solution for the problem. And modern tool uses, they could use any of the tools like C++, Python or anything, so that modern tool usage was achieved, communication was improved, and project management they were able to learn, lifelong learning also. So these are the some of the POs which were attained, and what we could draw the conclusion with this analysis, what we have done, the approach what we have followed, the problem-based learning and presentation of research-based approach has instilled as good platform for the students to look through a course in a better manner. The methodology helped its students to understand the course better, thus leading to good results in the semester and exams compared to earlier batches. Pedagogical approaches have aided the accomplishment of outcome-based education. The results clearly depict that approaches applied in the learning of OS course has helped us to attain PO such as PO1, PO2, PO3, PO5, PO9, PO10, PO11, and PO12. And these are the some of the references what we have done. Thank you.
Thank you. Just one request to all the participants that whenever you are presenting or whenever you're talking during your presentation, please turn on your video. Thank you. So thank you, Anita, for your wonderful presentation. I have a couple
Thank you,
of
sir.
questions. Yeah. Why PBL and research component been added in your, say, like one of the pedagogies?
Pardon me, sir.
Why you included PBL and say research component?
Actually, we thought problem since operating system has many concepts wherein they are supposed to learn the problems and latestly whatever is happening in the like so many applications are there with respect to operating systems. Like we use the operating system in washing machines, in most of the devices whatever we are using right now. So we thought we could use this problem-based approach so that they could derive the solutions for this.
Okay. Second thing, now there are a lot of universities who are coming with the PBL approach. So I would like to know how your PBL approach is different from the other.
We had actually taken smaller problems which since they are the students were belong to third semester, so we thought let them go with smaller problems what they will be able to find, and so that they will have a better learning. That's what we have thought, and we have included in our curriculum this problem based approach.
Okay. Can you go to the survey slide? Yeah, observations. Next slide, observations. Next, next. The graph you have like, okay,
Yeah.
review one. So this question is that you designed, right? A, B, C, D.
Yeah.
So how many participants were there for this question?
Approximately we took the survey from 100 students, sir.
Okay, 100 students.
Yeah.
So those students from your own college or
Yeah,
university?
my own institution. Yeah.
Okay, your own institutions. So how you picked those 100 candidates?
Whoever has registered for my course and whoever has gone through this particular review one as well as review two.
Okay. So was it a qualitative or quantitative analysis?
Actually, like we have taken the students whoever are registered, the whole set, whatever students participated in the activity, we have taken.
Mhm.
Yeah.
Okay. So thank you.
Thank you, sir.
Yeah.
Thank you for the presentation. And now we are moving forward to our next paper. And I would like to invite Anya TS to present her paper on the title Automatic Traffic Rule Violations Detection Using Deep Learning Techniques. So, dear presenter, you may please start your presentation.
Is it visible, ma'am?
Yes, it's visible. Please go ahead.
Okay. Sorry for the delay. My topic is based on automatic traffic rule violation detection using deep learning techniques. So today my contents are based on the topic I'm going to discuss is based on these contents like introduction, literature survey, existing systems, the system requirements, system testing, and snapshots of the results. So the intro of this topic is like you can see in our day-to-day daily life there are numerous number of vehicles that has been eventually gradually increased due to the populations that has been leading to traffic rule violation. The main reason for this is number of violations occurring that will lead to a human accidents like that. So the reason for these is like violating the rules like breaking traffic signals, overspeeding, driving on the wrong sides. So due to these kind of violations there is a lot of accidents happening everywhere. And that too in our developed cities it has been we have installed video surveillance big network to keep violations reducing, to keep an eye on the threats. So violations that include like detection of motorcyclists like who are not wearing helmets and triple riding and signal jumping, etc. So in order to simplify these traffic problems, an after identifying the violations, we automatic number plate recognition is also playing a very crucial role. So the main motive of this project is that to reduce the violations that has been occurred by the people. So these are the papers have been referred and referred to. And the existing systems like existing system, it relies on human participation where a police officer or a traffic policeman has to make sure an eye on all the vehicles that has been traveling. A police unit is being needed, so that is not possible in our day to day life to keep an eye on everyone. And another technology is to where traffic violation is by using camera that has been installed traffic rules. The goal is only just to detect the traffic red light crossing violations. So the problem statement and proposed systems are: problem statement is to design and develop a real-time detection of helmet violations, and also to detect the people who is violating the rules and to detect the number plate of them. And the proposed system is to detect the motorbike helmet, triple riding, single jumping, no parking using the deep learning technique. And after detecting to identify the traffic rule violations accurately, and detecting the number plate of the violations who have occurred, and sending an SMS alert to the vehicle. So this is a use case diagram of the traffic rule violations. First, the images will be occurred, and then we'll detect the vehicles, and it will check whether any violations are occurring like triple riding, helmet detection, signal jumping, no parking by the driver. If anything is violation has been detected, the number plate of that people who has been violated has been detected, and an SMS will be sent to them. So this is the activity diagram of the traffic rule violation detection. So if any violation has been occurred, it will go to the detection of the number plate detection, and it will detect, and that an SMS alert will be sent to the person. So for the system requirements for this is functional requirements are like the system must detect all the traffic violations, and it must recognize the open ALPR, that is automatic license plate recognition API. It should that will send text messages to the for that it will be used, and it should send SMS to registered mobile using Twilio API. Non-functional requirements are scalability, capacity, and usability. For that, at least the accuracy of violation should be more, and it should accurate like more than 0.8. Like, and capacity, it should be more data should be trained for this, and usability, it can be used in every other operating systems. And software tools required is like Windows 10. Software tool is OpenCV Python code has been installed. Coding language I've used is Python. And these are the hardware requirements which I've used. System Intel i5, hard disk 500 GB, RAM 8 GB. And this is the architectural design uh, of the traffic violation detection. First, the images is captured, and then collection of raw data, data cleaning, feature extraction has been done in the data collection and pre-processing. Then we apply the deep learning prediction model, where we CNN YOLO V5 algorithm is being used. Using those things, we'll detect the violations. Such as triple riding, signal jumping, helmet detection, and no parking. If any such violation has been occurred, a number plate of recognition has been done, and an SMS, it will send an SMS alert to the people who is violating. So these is the module descriptions, a camera, which web camera which is being used by the for detection, and YOLO V5 algorithm that has been applied for checking the detection to get an accuracy of the violations that has been occurring. And violations such as being helmet, a motorbike detection, a person who is not wearing helmet, a signal jumping, no parking, and triple ridings are such violations have been detected. And after the detection process, using OCR algorithm, that is optical character recognition, has been used to detect the uh, images of the number plate recognition, and an SMS alert has been sent using the Twilio messenger. So this is the algorithm design that have been used, but this is the workflow of the algorithm. First, data collection and data pre-processing uh, will be taken place. Then you will train the data sets. Then after that, YOLO V5 algorithm is used to classify the input data with the trained data. Then the YOLO V5 algorithm detects the violation, and the number plate is being extracted from the OCR, and then the SMS alert message will be sent using the Twilio messenger. And so I have done in unit testing and integration testing for each of the cases I've taken. For object I've taken for triple riding, and for helmet detection, for signal jumping, and for no parking. Integration testing, I've checked for the synchronization testing, whether it functions, it works for all the violations properly or not, and for triple riding detection. Results are like these are the results which have been given for testing, whether the image has been given, whether it detects the violation that is occurring or not. And this is the result I have been got. For applications, it can be used in a smart city implementation. We can implement in smart cities in tolls near shopping malls. And the conclusion is the aim of this topic is to build a better traffic monitoring system that will give a big relief to the general public and the government officials. So these are the references, and thank you.
Okay,
Any
Ravani,
question?
thank you. Yeah.
Thank you, sir.
So can you go to uh, the architecture part?
Yes, sir. The architecture.
Why you selected YOLO algorithm?
Sir, for better accuracy of detection
But it is
in
helpful for
real time.
only single
Real
detection,
time.
single object detection.
No, sir.
What
For
about
real time.
multiple object detection? Because if a person has a vehicle and he is going with his friend and it is a, say for example, two friends. So
Yes,
how
sir.
it will detect triple street,
For triple riding, sir. I've trained
triple
it
riding?
for triple riding detection.
But LO detects single object at a time, right?
Yes, sir. No, sir.
Uh-huh.
YOLO
So
is used for real time detection. So
yeah, it's
for
a real
multiple
time, but
detection.
and if you go to your results, can you go to your
Yes,
results?
yes, sir.
So here, the small objects are very difficult to detect if we use YOLO. Like for example, in your proposed model, you said like you will also detect the number plate.
Yes, sir.
So how do you mount the camera so that the number plate is also visible?
After the capturing of images, the number plate. After
Uh-huh.
capturing the number plate images,
Where is the camera?
sir, I've used for this project the web camera, sir, using my laptop.
Okay, so you have the data set, you prepared your data set.
Yes, sir. I've trained the data set using
No,
Kaggle
training is
one.
different. You created your own data set, like you went to the real example, like on road, and you captured the photos, and then you train on
Yes,
those
sir.
images.
A few images even I have captured, and few images I downloaded from Google.
Okay, and the fourth figure number 4 is
Yes,
the
sir.
image that you captured.
Uh, no, sir. That one I've downloaded. The few one which I've captured, I've not added in this result because the
Mhm.
clarity of that was not proper, sir, of that image.
Okay,
Similar like this kind only.
okay, thank you.
Thank you, sir. Sir, shall I stop sharing my screen?
Yeah.
Yes, thank you for the presentation.
Thank you, ma'am.
And now moving forward, I would like to invite our next presenter, P. Venkatesh, to present his paper on the title Deep Learning Based Lung Cancer Detection and Classification.
Hello.
Is it visible, sir? Hello?
Yes, it's visible. Please go ahead.
Lavanya, you can mute yourself.
Hello. Good evening, sir. Myself, my name is Podli Venkatesh, and my friends are Ravikiran and Bharat. And my project is lung cancer.
Venkatesh ji, can you just turn on your video?
Sir, I have using the uh, desktop, sir.
Okay, go ahead.
Uh, Coming to my project is lung cancer detect using deep learning and classification. For introduction, nowadays people are busy with their day-to-day work. They cannot observe the things in their body except which is when it occurs in external parts. So lung cancer is a interior disease which people cannot observe quickly and take any precautions in initial stage. Uh, there are 4 stages in the lung cancer. So when we detecting in stage 1, it will be curable, and the computer programmings like C, C++, these are not sufficient for doing the image processing. So we use deep learning. Actually, we have tested in ML also, but some issues faces like lack of quality data and implementation. So we use deep learning models as efficient net and ResNet 50. And our more main aim to focus is feature extraction and image segmentation using the models. And our project definition is CT scan images. We have taken the CT scan images and detect to whether a person suffering with lung cancer or not. And our objects and outcomes are we have taken the diseases like adenocarcinoma and and 3 diseases, and later it goes to the pre-processing stage, and later it developing the model and detect the lung cancer whether the person is suffering or not, and evaluating the disease results like metrics MNC, right? And these are the purpose I refer to. And first one is lung cancer disease using machine learning. uh, I observed that in this paper that the duplicate images are so many, so I have not to prefer ML, and I prefer deep learning. And I have taken 2 datasets, and the first dataset is 5 labels. I have taken 5,000 images as our dataset, and the 5 lung cancer diseases like adenocarcinoma, squirrel cell carcinoma, like that. And second dataset is 3 labels. We have taken 530 images as our dataset, and I have 3 datasets, uh, 3 labels. And this is our architecture diagram. First, we have taken the lung cancer disease data set, and later it goes to the data augmentation. In data augmentation, we have done what in this process data augmentation. The data is converted into many images like front, back, and rotating, like that. And then the data goes to the data pre-processing, and data processing later it goes to testing and training, and testing and training with using efficient net and RESTnet, and later it goes to the evaluating the data, and then results are obtained. And these are the implementation steps. We have taken CT scan images, and later the scanned images is divided into five labels, and the pre-processing data is used to clean the data and make suitable for model. It helps to increase the accuracy, and the data is divided into training and data, and later it used training data and validating data to evaluate the accuracy. This is our result, sir. We have used CNN, and later we used efficient net and ResNet 50. These are the accuracy we have got. Later we have ResNet 50, and we have got that 90%. And precision recall FN or the metrics we have used. And later efficient net we have got a 97%. And also we have calculated metrics like precision recall. In conclusion, for this project, we have successfully calculated the predicted the lung cancers. We have used that. We have used 5 labels. We have successfully detected, and in this coming to future work, by using this data, or we can future we can get how many are suffered and how many are future going to suffer in the next generations. These are some differences, sir. Thank you.
Thank you for your presentation. So can you just elaborate the data set that you have gathered or referred?
Sir, we have taken two data sets, sir. That we have taken 5
I'm
labels.
asking about the data source, like from where
Data
you
source.
got-
Oh, okay. So, sir, we have taken that lung cancer. We have not taken in real life, sir. So we have downloaded in Google, sir.
Google or GitHub or
GitHub only, sir. GitHub only, sir.
Okay. Then how you decided these labels? What is the thought
Sir,
process?
my my madam is suggested that these are the main cancers that frequently uh, people are suffering, sir. So I have decided to get only 5 labels, but we have taken 10 labels like that, but for doing 10 labels it is difficult, sir. So we have taken 5 labels only.
What do you mean by feature, and what are the features of your, say, model?
Sir,
What is feature?
feature.
Yeah. Once you take the data set, you extract the features, right?
Yes, sir.
So what are the features?
That feature, sir, we have for image classification, image extraction, feature extraction, uh, we have done that image data generator, sir. That data that image will rotates and give the duplicate image as like 4 to 5. So it will the image will see in all around, sir.
Okay, thank you.
Thank you for your great presentation. And now we'll move forward to our next paper. And I would like to invite Alik Chakrabarti to present his paper on the title Design and Simulation of Circular Patch and are having varied substrates and rectangular slits for 2.4 and 5.2 gigahertz. Dear presenter, you may please start your presentation.
First of all, good morning, Dr. Prashant sir, and even to all the participants and organizing ma'am. So I hope I'm audible clearly and even my presentation is visible.
Yes, you're audible and we can see your screen. Please go ahead.
Okay, thank you very much. So for the title of my presentation would be Design and Simulation of Circular Patch Antenna. So this is having varied substrates and rectangular slits of 2.4 and 5.2 gigahertz is the frequency band which I'm using for testing. So first of all, I'll go with the introduction section. My presentation mainly focuses on Wi-Fi applications, and the expectations for Wi-Fi in any home or office setting is that it gives faster speed and even for a wider range. Now, any radio communication systems would require antennas as its key components. And my reason for selecting microstrip antennas is present days they are having dipole antennas as the Wi-Fi system or Wi-Fi routers. But generally what happens, the power loss in microstrip antennas are quite less compared to dipole antennas, and even microstrip antennas, the threshold gain is quite better. So talking about the microstrip antenna, there are three types: microstrip patch antenna, slot antenna, and printed dipole antenna. But same to if we come to microstrip patch antenna shapes also, now there are another 5-6 patterns are there. My presentation would focus mainly on the circular microstrip patch antenna. The frequency which I have decided is 2.4 gigahertz and 5.2 gigahertz. This is unlicensed band and focus for Wi-Fi applications. And as we all know, the Wi-Fi application focuses, that is the Wi-Fi sector is primarily focused in retail routers, service providers, and enterprise devices. So talking about the antenna design and methods, first of all, I would say that my design is a microstrip circular patch antenna. It is consisting of single and dual layer substrates, and we'll understand in detail what is single and dual layer substrates, as well as here the substrate material which I have used are two different types of material. One is FR4 and another is Rogers RT4350. Talking about the rectangular slits, why do we use rectangular slits? We'll discuss also that in detail. I have used both single and dual rectangular slits to analyze the difference in the performance of the antenna. Fifth, we have the single and dual band frequency. And for the lumped port is which we use as a feeding line. And the material used for both circular patch and ground designing of the antenna is copper. And talking about the frequency band of 2.4 and 5.2 gigahertz, when we go ahead with the dual band application, we have to go ahead with the solution frequency or the resonant frequency. So the resonant frequency for this is analyzed using that formula root over FL and lower frequency plus a higher frequency. And we come to a conclusion that 3.53 gigahertz is the perfect resonant frequency for this antenna. So coming to the picture, figure dual layer substrate, dual rectangular slit, circular patch antenna. So as we all can see that here, so here there are two layers of substrates here. First one is the first layer of substrate, and this is the second layer of substrate. So this is the circular patch antenna, and I was talking about rectangular slits. So this is the rectangular slit. Generally, we cut it out to reduce the antenna size and increase the performance. And coming to the comparison table, I would firstly go with this. I have analyzed on 6 different types of antenna. First one we would be the single band, single layer substrate, single rectangular slit antenna, where the solution frequency I've kept as 2.492. And this is the mentioned substrate height, that is the height for this. And also the substrate material is mentioned over here, along with the substrate material permittivity value. So this is the S11 parameter that have been got from here, 42. So similarly, I've analyzed for another 5, and the perfect antenna which I can say right now lies, and I have inserted the picture also over here to understand the difference. We can say is dual band, dual layer substrate, that is, and dual rectangular slit circular patch antenna. And here is the S1 parameter of this antenna. So we can see that it exactly resonates at a frequency of 23 gigahertz and 18 gigahertz, which it sounds quite good for any antenna performance. Now let's talk about why this antenna type is exactly chosen. So first we'll go with microstrip antennas are among the best types because of its directional and broad radiation pattern. Secondly, the substrates used in antennas have the relative permittivity which varies from 2.2 to 12, where the lower is the permittivity, relative permittivity, the better efficient is the antenna, having larger bandwidth, but the size of antenna increases. So what happens is when so the reason for uh, when you are using FR for the substrate material, the dielectric or the permittivity value is 4.4 and the Rogers one is 3.66. So as we read over here that the lower is the relative permittivity, the better is the efficient. But now what happened when we increase here, if we come 3.66, we might feel that this is also quite bigger compared to 2.2 and the size of antenna gets increased. That is why we brought here the rectangular slits. That is, whenever the frequency shifts, then the initial design cutting a slit can bring adjustment to the expected frequency along with reducing the antenna size. So the upbringing of single and dual rectangular slits have helped in enhancing the bandwidth of the antenna, and also the area of antenna is also reduced. The implementation of substrates, why we have included substrate also matters. Simply this also increases the size. We have to justify this, and we see that the implementation of substrates increases or gives more mechanical strength and have good effect on antenna characteristics. The 6th point for the rectangular slit is it is having the capability of decreasing the solution frequency, which I have told earlier. So coming to the conclusion of this, microstrip patch antenna is designed for the Wi-Fi applications. So it can be used in both 2.4 and 5.2 gigahertz, having its own merits and demerits. Now the applicant can select the suitable frequency range based on application, what he desires. Now, if he requires something 2.4 gigahertz for greater coverage area, he can select that, or 5.2 gigahertz for maximizing network performance. So that will reduce lags. And the antenna designed in 2.4 gigahertz has larger range and greater coverage area, and the 5.2 gigahertz has greater speed that help with interference from neighboring networks. Thank you, everyone. Thanks to sir.
Thank you for your presentation.
Yes, sir.
So what are the main applications that you are focusing if it is to be implemented?
Yes. So coming to the main applications, the Wi-Fi sector is primarily focused in retail routers, which I have told at the beginning that Wi-Fi routers generally right now they're using dipole antennas, but I feel that microstrip antennas can bring more better performance in the antenna, and even the size also can be reduced here, and loss of power, all those things matter. So the primary focus for the Wi-Fi applications would be, I would say the routers would be the best place to introduce this first. Yes, sir.
Okay, thank you for your presentation.
Yes, sir. Thank you, sir.
Thank you for the great presentation. Moving further, I would like to invite our next presenter, Subhasini Sharma, to present her paper on the title Enhanced Dynamic Source Routing Based on Link Capacity and Queue Optimization in MANET, DSR-LQ. Dear presenter, you may please start your presentation. Subhasini, you can start your presentation. I think is facing some technical issues. So we'll move forward to our next paper. And I would like to invite V. Uma Karuna Devi Karkarla to present her paper on the title Positioned Stream Cipher Basing on Fibonacci Sequence.
Okay, ma'am. Am I audible, ma'am?
Yes, you are audible.
Okay, ma'am. Shall I share my screen, ma'am?
Yes, please.
Is it visible, ma'am?
Yes, now it's visible.
Very good evening, everyone. First of all, I would like to thank an entire team of ICTCS for giving me an opportunity to present my research paper entitled as Position Stream Cipher Basing on Fibonacci Sequence. Myself, KV Uma Karuna Devi, research scholar in Geetham University, Visakhapatnam, Andhra Pradesh. Here the main aim of my research article is to propose cryptography algorithms such as encryption and decryption algorithms based on Fibonacci sequence and its special property. In any cryptography technique like public or private key cryptography, the secret message is encrypted using a public or secret key. But in proposed method, no public or secret key is shared among the members of the communicating graph. The secret key is included in Fibonacci sequence and its properties. The proposed encryption technique uses the concepts of Fibonacci number sequences in generating stream cipher. In positional stream cipher, the encrypted messages and encrypted message characters are placed at different positions of the cipher bandwidth. Here, the proposed method protects the secret information from unauthorized persons. Next is introduction. In the recent years, with the increase of using internet and other new telecommunication technologies, it is necessity of every organization or a person to protect their sensitive data. Cryptography is an important technique used for protection of data. Cryptography provides privacy and security of the secret information by hiding it. The modern cryptography has significance to research in order to transfer data securely between two or more entities. It is done through mathematical technique like number theory. Even though there are numerous encryption algorithms exist, it is always doubtful. So it is necessary to introduce a secure and half-proof method to cybersecurity. The proposed method represents a new approach to encrypt and decrypt data securely with the use of exclusive OR operation, Fibonacci sequence, and its properties. The proposed encryption algorithm processes the plain text in a character-wise from the beginning. Finally, the generated cipher characters are shuffled by using the positions of the characters determined by the special property of Fibonacci sequence. Here, the proposed methods are Fibonacci sequence and Fibonacci position generation, proposed encryption algorithm, proposed decryption algorithm. Here, the next are Fibonacci sequence and Fibonacci position generation. Here, we use the Fibonacci sequence and its property to generate positions. By using these positions, ciphertext characters are shuffled. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, and so on. Here, the first two numbers in the Fibonacci sequence are F0 and F1. Here, we said here F0 is equal to 0 and F1 is equal to 1. Here, the every term in the Fibonacci sequence is sum of previous two terms. That is, Fn is equal to Fn minus 1 plus Fn minus 2 for n value is equal to 2, 3, and so on. Here we consider a special property of Fibonacci sequence. That is, if we consider 4 consecutive Fibonacci numbers as Fn, Fn plus 1, Fn plus 2, Fn plus 3, then the arithmetic expression Fn plus 2 cube minus Fn cube minus Fn plus 1 cube is exactly divisible by the fourth number, that is Fn plus 3. Next is proposed encryption algorithm. Here the proposed algorithm consists of 8 steps. The first step represents the input. Here we consider the plain text or original message as the input with the size n. Then we convert these characters in the plain text into ASCII binary equivalents. In step 2, we consider a Fibonacci sequence with length equal to n from f2 to fn minus 1. Here we ignore first two numbers in Fibonacci sequence, f0 and f1. Here we consider from f2 to fn plus 1. All the Fibonacci numbers are adjusted to mod 256, and these adjusted Fibonacci numbers are also converted into corresponding ASCII binary values. In step 3, we apply logical exclusive OR operation. Here the exclusive operation is applied between the message characters m1, m2 and so on mn, and the Fibonacci sequence is from f2 to fn plus 1. Here the nth ciphertext character, that is CNB, B represent binary form, that is equal to ASCII of mn exclusive OR operation of fn plus 1 for n value 1, 2, 3 and so on. In this way, we calculated all the ciphertext characters from C1 to Cn. In step 4, the binary numbers C, ciphertext 1, ciphertext 2, and so on, ciphertext n, cipher character n are coded into ASCII symbols. The proposed encryption technique represents a positional cipher. So here the encrypted cipher characters which are obtained in step 4 will not appear in the same order as M1, M2 and so on Mn. These characters are shuffled by using positions. These positions are calculated with the special property of Fibonacci sequence. That is, if 4 consecutive Fibonacci numbers are considered as Fn, Fn plus 1, Fn plus 2 and Fn plus 3, then we apply the arithmetic expression. This arithmetic expression is divisible by Fn plus 3. This arithmetic expression is used to calculate the final positions of the stream cipher. Next, proposed decryption algorithm. Here we use the symmetric algorithm as the cryptography. So here we apply the same process for decryption operation also. Whenever the receiver receives the ciphertext, first constructs the position table using the length of the ciphertext. Next, arranges the jumbled ciphertext in proper order. Then we apply the reverse logical exclusive operation using Fibonacci numbers to get the plain text. Here, the equation for the plain text character mn is equal to ASCII with the binary value of Cn exclusive OR of Fn plus 1. For n value is equal to 1, 2, 3 and so on. Next is results and discussion. This table represents an example. Here we have generated cipher binary CIB and Fibonacci positions Fp of n for considered plain text. That is Venkatuma Karunadevi with length 20 characters as M1 to M20 using Fibonacci sequence. Here we have different columns. The fourth column represents plain text Mi. Next, in fifth column, we have ASCII binary equivalent of plain text characters Mi. Next, we consider a Fibonacci sequence with the length n is equal to 20. The first column represents the Fibonacci sequence from F2 to Fn plus 1. Next, in second column, we adjusted these Fibonacci numbers to 256. In third column, we calculate the binary equivalents of each adjusted binary Fibonacci numbers. Next, the binary numbers are coded to ASCII symbols as cipher characters. Finally, we shuffled these cipher characters using positions. We calculate the positions by the help of property of Fibonacci sequence and adjusted to mod n. Here n is equal to 20. This table represents generation of encrypted text or position stream cipher. Okay, in this table we have two rows. The first row shows the input text, that is plain text characters, and the second row represents the desired output, that is positional cipher text. Here we have the table. This table represents the execution time of Fibonacci numbers, Fibonacci positions, and total execution time for a given number of characters. Here, we developed math code for Fibonacci numbers, positions. Okay, in this table, we have the execution time for different sizes of data like n is equal 20, 50, 100, 200, 300, 400, and 500. Here, we generated these execution time values by using MATLAB. Here we have the graph. This graph shows the execution time for different sizes of data. Next, conclusion and future work. We attempted a novel method to protect secret information from unauthorized persons. For this, we proposed a Fibonacci sequence generation, encryption, and decryption algorithms. The proposed encryption algorithm is based on Fibonacci sequence and its special property. Each message character is undergone logical exclusive operation with corresponding Fibonacci integer. Streamwise, bitwise exclusive operation produces strong encryption system used in modern ciphers with confidentiality. To avoid the security attacks and to protect the confidentiality of the ciphers, one way is jumbling the cipher. Here, each encrypted character is shifted to different positions from its original position using proposed Fibonacci positions. Here, the algorithm is secret between communicating parties rather than secret key. The encryption technique can be further improved by using different other properties of Fibonacci sequence. Thank you.
Thank you for your presentation. First thing is why position ciphering? Why are you using position ciphering?
So we have different types of ciphers as block cipher and stream cipher. Here we consider one character of the plain text at a time. So here each input character is converted into 1 byte of binary value, sir.
Why not the other ciphers like Caesar cipher or substitution cipher or AES and DES? What is the thing that you are achieving if in using positioning cipher?
Here we have no key, sir, to encrypt or decrypt the message, sir. Here we use only Fibonacci sequence and special properties to encrypt and decrypt the data, sir.
Okay, in that case, if the algorithm is known to sender as a receiver, and in between, suppose there is a hacker, he also will follow the same steps.
Yes, sir. So that's
Then,
why here the algorithm acts as a secret key, sir. So the algorithm is secret between the communicating parties, sir.
So how you say like secret?
Here the
Go to the conclusion slide.
sir.
The algorithm is a secret between communicating parties rather than the secret key.
Secret key, sir.
So how do you ensure that it is secret between source and destination only? Hello?
Oh, sir.
Yeah.
Oh, sir.
Okay, thank you for your presentation.
Thank you so much, sir. Can I leave, sir?
Yeah, thank you so much.
Thank you, sir.
Thank you for the presentation. And moving further to our next paper, I would like to invite Rakhi Bharadwaj to present her paper on the title Real-Time Indian Sign Language Detection.
Ma'am, could you stop your presenting screen? Yeah, thank you.
Hello, Parag. Are you presenting on behalf of Rakhi?
Yes, ma'am. Yes, ma'am.
Okay, go ahead.
Yeah. Is my screen visible?
Yes, it's visible.
Okay. So good evening, everyone. I am Parag Godebole, and I am presenting the topic that is a real-time Indian Sign Language detection along with my group members. So these are the group members, Shubham, Pratham, and Mohit. So this is a brief outline of our today's presentation. So let's begin. So we all live in a society, right? And the main important one of the main aspect of living in society is the communication. So according to WHO, around 1.5 billion people around the worldwide are suffer from hearing loss, and around 50 million people are affected by a speaking problem, right? So these people have major issue while communicating with each other. So there are some solution for that, like text messaging, writing, visual media, finger spelling, right, guys? But this solution always not gonna work, right? So there should be some generalized solution to communicate with each other, and for that the sign language will be the greater option. So basically the sign language is the non-verbal communication language, which will in that we show the some hand gesture for particular word, right? And we chose the Indian Sign Language for developing our system. And the deaf people and dumb people know that particular sign language, but the normal people doesn't understand or know knowledge of that particular language. So there should be some system that will help to understand that particular language to normal people. So that's our project. We are building the system that will convert the sign to their respective text, or we can say the audio format. So it will help to understand that particular language to the normal people. So moving ahead. So this is the some pictures that are of sign for particular alphabet sign number. Yeah, moving ahead to objectives. The main objective of our project is to generate the well-level data set of Indian Sign Language, so that the model could get the better accuracy. Also, we want to train our model such that it will recognize that the hand gesture in real time. And for the capturing that particular hand gesture, we will use the webcam. Then also the system should provide the audio and the text responses of that particular recognized sign. And the system should provide the platform to learn the hand gesture of different signs. It means if someone wants to learn the particular sign of some word, so it will simply speak out that particular word, and the appropriate sign for that word will be the shown as an output. So that's the fourth objective. Yeah, so the project is comes under the computer vision and machine learning domain, and the tools that we majorly use is the Jupyter Notebook for coding, and the label image, that is a Python-based platform for labeling the image. And the technology stack that we are using is the Python as a programming language, and its libraries like OpenCV, TensorFlow, and NumPy as a for other purposes. Yeah, so I will hand over the further presentation to Pratham. Yeah, Pratham, go ahead.
Now the methodology that we have followed for this project is that first step is to collect the images for preparing the data set of the hand signs. So using that data set, first another step was to crop our images so that we capture the main content of the image, that is our hand, and that is done using one tool that is called label image. And further, after we have taken the image which is required, we do the segmentation, pre-processing, and feature extraction, for which we have used a model which is TensorFlow mobile SSD model, which will do the work of processing, and we get the trained model from that. So after training, the model can recognize the images that we have given as an input, and after recognition of the sign, we get the output in the form of text and audio. So the text will then be converted into audio, and we can hear the audio. And similarly, we have also done a vice versa system, where if we speak, so that a person who is able to speak can help to communicate with a deaf or dumb people. The audio, if the person speaks in the audio format, that is being converted into a video, like a video comes up according to the text that is being converted from that audio. So this is the complete methodology that we followed. Further, these are the results that we obtained from our model. That is, we can see the left side is the digits and right side is the letters that we have, and it is being colored using a bounded rectangle, and above that we can see the accuracy that we have for that particular sign. Further, now we can go through a demo which will show the output in the form of video. So for you can go.
You are pointing 1. You are pointing 1. You are pointing 0. You are pointing 0. You are pointing 5. You.
So now this is the words that
You are pointing good.
the person is showing using the hand gesture.
You are pointing wrong. You are pointing nice.
Welcome.
Now this is the demo of audio to video.
Accident.
Now we will go through the limitations of our project. Basically, the system now we have created is just an input and output in the format of input and output. But further, we can improve our project by providing an eco-friendly, means friendly interface for communication between both the parties. And the main limitation you can say is that the amount of data set that we have used is less, because we don't have much of the images, and that's why the accuracy for some signs is 70 to 75%. Also, the for while prediction, the output that comes in the text format sometimes fluctuates due to the movement of hand movements, because the hand movements can change according to the person while showing the sign. And also we have tried creating sentences out of words, but it becomes much difficult as because of the less accuracy and the fluctuation of the output data. So these are the limitations. As in future scope, we can improve the accuracy by enlarging our data set by taking more and more images of a particular science. And also we can further identify sentences if the accuracy is more up to 90 to 95%. And we can further improve this system by adding more features, which is like eco-friendly GUI that I said. And also we can recognize some human facial expressions from the video of a person. And also the model can be improved such that it recognizes signs in different languages. So this is the future scope. These are the references that we used for our research. Thank you everyone.
Thank you for your presentation.
Thank you, sir.
Thank you, sir.
So, do you have developed any app wherein this could be used effectively?
Not yet, sir. We are planning to build an Android app so that it is very useful for the common person as well.
Okay.
But
Second
it
thing,
is currently
are you targeting 2 words at a time instead of 1 word?
we have
or
not
digit?
tried, sir, but our model is able to detect both the word. Like we are using SSD model, like SSD mobile net, which is single shot multi-box detection. So it is able to detect multiple objects in one frame. And for the safety purpose, we are like frame rate, we are keeping like 1 frame per second. So we
If
have
you're taking 1 frame per second, what is the complexity that takes it? Or what
what,
would be
sir?
the complexity? time complexity I mean, how much time it will take to detect and convert into the appropriate format and revert back to the user?
Sir, actually, it is very fast. That model is very fast. We haven't calculated it, but it is in the microsecond. But just for the frame stability, we have considered the frame rate as 1 second, like 1 frame per second, so that the whatever user is showing to the camera, it will get captured by that model. So
Okay, thank you so much.
Thank you so
thank
much,
you.
sir.
Thank you, Parag, Pratham, and Shubham for your great presentation.
Thank you.
And moving forward, I would like to invite our next presenter, Shambhavi Mukherjee, to present her paper on the title Speech Emotion Recognition Using Convolutional Neural Networks on Spectrograms and Mel-Frequency Cepstral Coefficients Images. Dear presenter, you may please start your presentation.
Yes, ma'am. Ma'am, is my screen visible?
Yes, it's visible.
So, good evening, everyone. My name is Shambhavi Mukherjee. Ma'am, should I turn on the video?
Yes, you can on the video, please.
One second. Good evening, everyone. The topic of my presentation is speech emotion recognition. I'm a BTech undergraduate from Manipal University, Jaipur. So humans communicate by speech and language, and along with linguistic content, speech is rich in information about the speaker, such as gender, age, and their emotional state. The linguistic content, only when combined with the paralinguistic features, can tell us about the true meaning of the speech that is being delivered. So despite speech emotion recognition from speech being a relatively newer topic of research, it has a wide range of applications. It can be used in auto-generated subtitles. It can be used in live speech transcripts and intelligent chatbots such as Alexa and Siri. It also has a wide range of applications in marketing and in
Your
the field
screen is
of
not
medicine.
visible.
It's not visible. So it has a wide range of applications in the field of marketing and in the field of medicine for psychology. The majority of emotion recognition has concentrated on the usage of speech descriptors such as Mel frequency, spectrum coefficients, linear prediction coefficients, energy, spectral flux, etc., followed by the application of a classifier such as SVM, naive Bayes, or an ensemble of all of these. In other research papers, they focused on converting the speech recognition task into an image classification task by converting the audio files into images and using the MFCC images basically, and training the models, CNN models, and predicting the results. But in our technique, we basically also gathered MFCC images and as well as spectrogram images and trained CNN models. So spectrograms are basically graphical representations of signal strength or loudness of a signal across time at various frequency contained in a waveform. So we drew a comparison between the CNN MFCC model and the CNN spectrogram model. And the spectrogram model showed an improvement in accuracy by 3.75%. So these are the related works. So in the dataset we chose for our experimentation was called the Urdu dataset, which contained 400 emotional utterances with 4 basic emotions, which are angry, sad, neutral, and happy. And they were uttered by 38 speakers, out of which 27 were male and 11 were female. So this bar plot shows that there are 100 files of each of the audio basically emotions, and there's no class imbalance. So we tried to combine both machine learning and deep learning approaches to achieve the speech emotion recognition task. On the above, we see that there's a flowchart in which we convert the audio files. We extract the features basically using a library called Librosa, which is a Python library for speech recognition. And then we apply to the traditional level classifiers to get our predicted emotions. And in the below image, we see that the audio files, we've basically extracted spectrogram images and MFCC images, and it's followed by a CNN architecture, which performs the classification task. So for the pre-processing, we took the audio files and using a Librosa library, we use the audio files, we considered them for 2.5 seconds, and considering a resample type of Kaiser fast and sampling rate of 44,100 hertz and an offset of 0.5 seconds, we basically did our pre-processing, and the feature.mfcc method that is in Librosa, we considered 128 MFCC features, and which converted our audio files into vectors of 216 dimensions. And considering a lot of train test splits, the best that we achieved was using 80-20 split. And after that, our model could be, the dataset could be fed into machine learning algorithms. So coming to the CNN architectures, we basically extracted spectrogram images using a library which is known as Open Soundscape, which produced images of 224 by 224 pixels. And using the Librosa library, we extracted MFCC features, no pictures, and it gave for 2 seconds basically. And after that, we can apply the CNN architectures. So this slide shows the pre-processing task basically. So the audio signals, they were in a time domain. So they using the pre-emphasis and frame blocking and windowing, they were converted into the frequency domain. So in pre-emphasis, what we do is that we eliminate the higher frequencies, so that because human ear is only it only detects variation at a lower frequency. And in frame blocking and windowing, since the audio files are basically time varying, we consider small windows of it, where we can consider them as stationary and perform the pre-processing. So after applying short-term Fourier transform, we basically have 26 filter banks, which are known as MELD filter banks. Based on the frequency ranges, it basically generates features for us. And after that, the features are decorrelated using discrete cosine transform, and we finally get the MFCC images. So using the logistic regression, we got an accuracy of 51.25. Using SVM, we got 68.75. Using random forest, we got 69. And for using naive Bayes, we got a 67.5% accuracy. Using a weighted combination of 3 of the machine learning models, which are naive Bayes, random forest, and support vector machine, in a weighted combination of 0.05, 0.55, and 0.45, we got an accuracy of 70%. Now coming to the deep learning architectures, in the down part, we see that there are, this shows the spectrogram image, and on applying the CNN architecture is basically we have 3 convolution layers and each followed by a max pooling layer. Finally, it is flattened and fed into dense layer of 128 neurons. And finally, we have an output layer of 4 neurons because we have 4 emotion classes. So finally, applying this for 70 epochs, we finally get an accuracy of 86.25%. And this slide shows the accuracy versus epoch graph, and this shows the performance report. And using a similar kind of architecture and using the MFCC images, below we can see the MFCC image. This is how it looks like. And using it for applying it for 50 epochs, we get an accuracy of 82.5%. So we see that the graph flattens at 50 epochs, so we had to stop there. And this is the performance report. So finally, we applied a majority voting rule, which combined machine learning and the deep learning approaches basically. So we got an accuracy of 78.75% in this, and this might be seen as a decrease in accuracy, but it proposes a more generalized model because we're combining both the strengths of the signals, the speech features, and the image features. So this shows a comparative analysis, the confusion matrix of all of the models that we've experimented with. And this shows the AUC ROC curves for each of the model. And these are the conclusions. And finally, this shows the class-wise accuracies of all of the emotions and all of the models that we have experimented with. And for the future work, we can generalize it by applying a different kind of data sets. And we also want to consider more number of features along with MFCC. We also would like to use a wave-to-wake model, and which will give us the vectors from the audio files, and then we can apply any of the classifiers. And we can also use speech to text, and finally apply LSTMs on them. And these are my references. Thank you.
Thank you for your presentation. Could you just elaborate the approach which is being used to address the issues of speech emotions?
So which has been in this paper?
Yeah.
So we've like combined both the machine learning and the deep learning tasks. We have applied logistic regression, support vector machines, random forest, and naive Bayes, and an ensemble of these machine learning models. And for deep learning, we have taken 2 CNN architectures. Yes, sir.
So what is naive-Bayes classifier?
So the naive Bayes classifier is it basically is a classification algorithm. It is a supervised kind of algorithm which uses conditional probability, and the Bayes theorem also is considered in it.
Okay, and in your say speech recognition problem area, what are the different variables that you are considering in the naive Bayes classification, which are independent with the other one?
So in naive Bayes, so what is your question?
So naive Bayes is undoubtedly is a probabilistic based approach where it takes the independent variables. The instance of a one variable does not have an effect. Or so what are the independent variables in your context?
Yes, so the features that we are getting, like it's generalized for all of the models that we're taking, all of the features that the 216 vector, the dimension vectors that we are getting. So all of these are like being considered as individual
How many features you have? How many features you have?
So 128 features MFCC.
128.
Yes, sir. Yes, sir.
How do you decided 128?
So we tried with other like less than that also, but the best accuracy we got from this only.
So how do you concluded it is 128, not more than or not less than?
No, so there's a parameter that we have to specify.
Okay. So there is no specific thought to select 128. You looked into the accuracy and you concluded when the accuracy is good.
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you, Shambhavi, for the presentation.
Thank you.
And at last, I would like to invite Subhasini Sharma again to present her paper. Subhasini, am I audible?
Yes, ma'am. Yes, ma'am.
Okay, so if you have got the connection, then you can please present your paper again.
Hello, ma'am.
Yes, Subhasini.
Ma'am, is my PPT slides is visible or not?
Yes, it's visible now. Please go ahead.
So, good evening, ma'am, and welcome to my presentation. So, first of all, let me thank you, ma'am, for giving me this opportunity to present my presentation here. As you know, my name is Subhasini Sharma, and I am a student of MTech Computer Science Engineering in Rajiv Gandhi Pradhyogiki Vishwavidyalaya from Bhopal. And the topic of my presentation is enhanced dynamic source routing protocol based on link capacity and queue optimization in MANI. And the purpose of my topic is providing better results as compared to dynamic source routing protocol based on path reliability. and link repair mechanism that can be used in multiple fields like military application, environmental application, industrial sensing, health application to automobiles and agriculture applications. And this topic is under guided by Dr. Kiran Pandey. So coming to the next slide. So this is an index. So I will cover up all these things one by one.
Just to interrupt, can you go to
Yes,
the
sir.
proposed work directly?
Okay, sir. Yes, so this is my proposed work. So in this proposed work, we propose the enhanced dynamic source routing protocol based on link capacity and queue optimization for balancing the load and rate-based congestion control in managed environment that ensures in dependable and efficient communication while also being cost effective. And the DSR routing system establishes reliable path between sender and the receiver. And sender makes use of these various channels to convey their data to the receiver, which helps to keep the network's load balanced. Now, anytime some sender wishes to transfer their data, so it employs numerous paths and at each step, and then it's measured the end-to-end latency as well as the normal time without congestion. So acknowledgement delay difference, which is it's then stores in memory. And the large number of senders and receivers share a single mobile node, causing congestion in the network that is unavoidable. So in this scenario, each sender compares the new acknowledgement delay difference with the previous acknowledgement delay difference. And this figure is shows this scenario. Here is source node and destination node are and multiple neighbor nodes that can be used to connect and exchanging their information in form of packet sharing, data packet sharing. So coming to the next slide. So in this figure, there are three routes are available. So first route is S A B D. Second is S C D. Third is E F G. E F G. So the first route selects for route selection for because of the acknowledgement delay and light traffic on link. And third route is also better but hops count more. And the second route is chosen for minimum for lowest traffic in the load. So if the sender notice that the delay is rising in comparison to prior recording time, the data rate is changed. It is applied to each TCP sender node, and each sender node alters its fundamental data transmitting rate in response to their reducing congestion in the network. And this bandwidth estimation technique is achieved using the acknowledgement delay data. Another study for congestion control is the use of dynamic queue management technique. So in this technique, a dynamic queue is implemented at each node of our network in order to reduce congestion caused by queue overflow as much as possible. By utilizing this technique as a foundation, we may reduce congestion and raise the percentage of receiving the data in network and as well as decrease the average end-to-end delay of the network in general. So this is a proposed algorithm. So there are 7 steps. So in first step, we creating a mobile node with letter M, and in second step, configure the routing protocol to be DSR, and in third step, we are changing the sender to S, and which is belongs to M, and in fourth step, we to set the destination D, and then B create the radio range that is, B set the radio range that is 550 meters, and then node energy. And for media access control, we using the MAC address 802.11. And in this steps, B is a root request is sent from the sender to their next neighbor. And if the next neighbor is equal to destination and the next neighbor is under the range of 550 meter, and also node energy is greater than 0, then in this case, if next neighbor is equal to destination, then create a route table and check the more than one route table, and then send the route acknowledgement to the sender node, and then start the data transmission. Else, in another condition, if the else, so the route requested packet accepted, and B route request packet forwarded to their next neighbor, and forward route request packet till destination node found. Else, check the route request limit time. If route search time is greater than limit, then we exist this process. Else, check the route request limit time again. So coming to the next slide, which is congestion management procedure. So here also there are 7 steps. So in first step, sender S transmits a data packet to destination D using the shortest path possible. So second step we calculate the total amount of incoming and existing data from each node and value obtained from the trace file. And in third step, calculate drop data packet from each node. And in fourth step, analyze the trace file to determine the region for the drop. And in fifth step, if drop region is equal to collision or congestion, then we check the queue status for handling the load. And in sixth step, if queue is greater than maximum value and packet request is equal to packet forward, then calculate the incoming packets rate exceed the available capacity, and then increment queue capacity for link quality. And then for managing data rate, use the TCP acknowledgement based technique. And in step 7, if old acknowledgement time is greater than new acknowledgement time, then no need to adjust the data. Here T is the time. So continue routing with the same data rate. Else, select new data rate, and then new data rate is half of the actual data rate, improve LQ. And then update route and select lightly loaded route, and then select lightly loaded route with minimum host time. So coming to the next slide, which is simulation tool. So network simulators. So the network simulator is a software program that can predict the performance of computer network or wireless communication network. And the use of network simulator are in machine learning, education, defense based on MANET. And this is the version of NS 2.31 stands for network simulator, and it is open driven simulator design especially for research in computer communication network, and it is uses 2 languages.
Can you conclude? Can you conclude?
Yes, sir. So this is the results. This is the simulation parameter scenario, and sir, these are the results of our presentation, our paper. So the conclusion, in this work, we have proposed the enhanced DSR LQ in MANET for balancing the load and control the congestion for buffer capacity and link capacity directly affected heavy load in network. And the performance of previous DSR dynamic source routing protocol based on path reliability and monitoring link repair showing better result, but their utilization of resources is very poor. And the proposed And this proposed dynamic source routing, link capacity, and queue optimization, showing the improvement in performance and utilizes the resources efficiently for better performance. So in future work, and so in future, propose the high data. It may be possible. So high data rate technology like 5G or 6G for communication with MANET and compare the performance with current approach. And these are the references of this presentation.
Okay. What are the different
Yes.
routing protocols?
Yes, sir.
What are the different routing protocols?
Different routing protocols like DSR, AODV, or AODV,
Have you done the
TORA,
analysis
J.
of have you done the analysis of all the routing protocols against few parameters?
Yes, sir.
What is the conclusion?
Yes. Sir, can you again?
If you know all the routing protocols, have you compared and done the analysis?
Yes, sir. I am
what is the
compared
conclusion?
its from DSR PM as routing protocols, and
What
their
is the conclusion?
So, according to the results, these are so these protocols are providing better results as compared to previous approaches. So,
Okay. Thank you so much.
yes, sir. Thank you, sir.
Thank you, Subhasini, for the presentation. Now that we are done with all the papers, I
Yes, ma'am.
sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 6th version of the conference. And we will be happy to have you in the 8th version in 2023. So all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. The publication will be live within 6 months. So kindly cooperate with the team of ICTCS 2022. I also like to thank our session chair for chairing the session. And here is a small token of appreciation on behalf of Team ICTCS and Global Knowledge Research Foundation. Professor Prashant Dotre, thank you for your valuable presence, sir.
So thank you so much, Madam Anisha and GR Foundation for this wonderful opportunity. And I must thank and congratulate all the authors who presented their best to deliver the knowledge in this conference. All the papers are really good and appreciated. And thank you, Madam Anita, for wonderful cooperation and support. See you.
Thank you so much, sir, for your kind words. Now, as we have come to an end of the session, I request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.